We are asked to differentiate the function y equals t divided by the square of t minus 5. We might realize that we have a function in the numerator and a function in the denominator. Since that is the case, we could define the function in the top, the function in the numerator, as f of t equal to t, and the function in the denominator, g of t, equals the square of t minus 5. And something that we might realize is that we could square t minus 5, multiplying that out. We would wind up with t squared minus 10t plus 25, which may come in handy later. In order to find this derivative, we would need to use the quotient rule. The quotient rule tells us that the derivative of a quotient of functions f over g can be found by multiplying the bottom function g times the derivative of the top f prime minus the top function f times the derivative of the bottom function g prime, and then dividing that difference by the square of the bottom function g. So g times f prime minus f times g prime divided by g squared. This is often described as the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the square of the bottom. So our function is y equals t divided by the square of t minus 5. So we will write y prime then as the bottom, the square of t minus 5, times the derivative of the top, the derivative of t is 1, minus the top, so minus t, times the derivative of the bottom. Since we can write the square of t minus 5 as t squared minus 10t plus 25, we can find that derivative then as 2t minus 10. Then we should divide by the square of the denominator. Now we might realize that there is no need for us to multiply by 1, it doesn't change anything. And then we might also realize that in the second term, we could factor a 2 out of the two terms in the parentheses. This would result then in y prime equals t minus 5 squared minus 2t times t minus 5 divided by t minus 5 to the fourth. Now we might realize that in the numerator we have two terms separated by this minus sign. And we have a common factor in these two terms, and that common factor is t minus 5. So we could factor a t minus 5 out of the two terms in the top. Then that would leave us with t minus 5 minus 2t in the other factor. And we still have t minus 5 to the fourth in the bottom. But we see now that we have a common factor in the top and the bottom that can be canceled. This would leave us then with t minus 5 minus 2t divided by t minus 5 cubed. Then we could combine like terms in the top, and we would find this derivative as negative t minus 5 divided by the cube of t minus 5.